So now we're going to solve a system of equations by substitution. And it's actually very simple and very useful in cases like this where we have two equations in standard form instead of slope-intercept form. So the first thing we do is decide which equation we're going to start with. And I always try and start with the easiest looking one, meaning there's no coefficients in front of one or more of the variables. So I'm going to use our first equation, and I'm going to turn it so that y is by itself. So I'm going to subtract x from both sides, and I get y is equal to negative x plus 8. Now, for the substitution part, I'm now going to take this chunk and I'm going to plug it in to this second equation wherever I see an x. So I'm going to write the second equation to start. Organization, right? And then I'm going to take this equation, and wherever I see y, I'm going to plug in this. So 3x stays. Now I have two y's, or I have 2 times the negative x plus 8, and that equals 14. You'll notice now y no longer exists in this equation because we substituted this green chunk in for y. It equaled y, we took y out, and we put negative x plus 8 in. Now I'm going to use my distributive property. And I'm going to get 2 times negative x is negative 2x. 2 times 8 is 16, and that equals 14. 3x minus 2x is 1x plus 16 equals 14. I'm going to subtract 16 from both sides, and x is going to equal negative 2. Now, I can plug in this negative 2, which is 1/2 of my solution, into either of these two equations that we started with. I like to use the easiest one, the one with the least amount of work, and so I'm going to use x plus y equals 8. We know x is going to be negative 2. We're solving for y. So negative 2 plus y equals 8. Inverse operations tells me I'm going to add 2 to both sides because those cancel. Canceled over here too, we forgot that one. And y equals 10. There's the other half of my solution. So our point of intersection is negative 2, 10. That is the solution to our system of equations. That's where the two graphs meet.